This is a bonus video for the C programming series, and we learned about arrays. I didn't have time in that video because I want to try to keep all these videos less than an hour. I didn't have enough time to talk about one extra feature in arrays, and that is the two-dimensional array or multi-dimensional arrays. Now, in other programming languages, you might be able to define something as an array. There might even be an array data type, and you would just tell it immediately this is going to have multiple dimensions to it, like an X and a Y sort of dimension to it. Not the same in C, right? You need to do a lot of stuff in C kind of by hand. For that, you need to create an array in a slightly different way. And so let's take a quick look at how to do multi-dimensional arrays in C. So just picking up where we left off, let's do a simple program just to show combining arrays. So we'll do this one as 2D array .c, and we're going to do just as we did before. We're going to include our standard I/O. We're going to use malloc, so we should probably do the standard lib. Oops, standard lib. Now, when we and our main function is right here. Now, when we learned how to do arrays, we had a single dimensional array that we defined using star. Int star says this will be a pointer to something, and the pointer is what we use for arrays, and then the name of the array, right? So a single star says that was a single dimensional array. I'm going to have an array here that's going to be 2 dimensions. It's going to capture, let's say, X and Y. Like I might use this on a game if I want to look at the characters I'm putting on the screen. I might use it in a math problem if I want to keep track of multi-dimensions of stuff. And so how do we create a 2-dimensional array? Well, if 1 star is giving us a pointer to one array, 2 stars gives us pointers to a 2-dimensional array. And so let's go ahead and create a couple other variables to go along with this. So we're going to do a variable called the number of rows. And this will be, let's say, a 3-row array. So it's going to go Y from 0 to 2, 0, 1, and 2, 0, 1, and 2. How many columns will it have? Well, it might have columns is going to be, let's do 4. Just, I don't want it to be big here. So the 3 by, or really a 4 by 3 array, but we're going to put it in the other way, other order. And then let's actually have some variables to count with, and we'll do Y and X. So let's first of all allocate our memory. Now, we did it before by allocating memory for a single dimensional array. We just had to do it once. Well, that's all you have to do here for doing the first one. So we're going to do array equals, and this is remember, it's an integer array, so int star. And we're going to use malloc. Okay, so how big do we need to have? Well, this is the challenge. How big do we need this to be? Well, don't overthink it. What we're trying to do is we're trying to have how many rows, and then how big is each one? Well, we do the size of, and before we did the size of like an int, except that's not what we're storing here, right? This is an array of arrays when you think about it. So how big is a pointer? So it's a slightly different way of allocating the array, because the size of isn't the size of an int, the size of int star, the size of a pointer to an integer array. And then we're going to have that number of rows. Now, if that worked, let's first of all test if that, or sorry, if array has null, well, then we know it failed. So let's go ahead and do a quick test for that. Put S. Say oops. Would not allocate array. And then we'll return back the operating system with 1, because that'll give an indication of an error. If it did work, then it'll proceed. So what do we do next? Well, this is a 2-dimensional array. So I've got, what I've done here is I've reserved enough room for the number of rows, right? It's going to have 3 rows, and each row itself is another array. And that's the trick to two-dimensional arrays, is that it's really an array of arrays. It's a list of lists. So we're going to do, we now need to allocate each row. And so we need to have our loop for y equals 0. We're going to start at 0. Y has to be less than the number of rows, because it's going to be going from, in this case, 0, 1, and 2, because all arrays start from 0. And then y equals y1. And so what goes inside that, I want to now allocate each of my rows to store a certain number of columns. So we're going to do into array element number y. We want to store, again, it's going to be, it's going to be an integer array. I do that variable cast, and there's our malloc. And how wide is this? Well, this is going to be a certain number of columns times the size of an int, because I'm actually ultimately going to be storing a number in there. So not doing int star, because I'm actually allocating room for each of the rows now. So doing size of a single int. Now, if something really went wrong, I would probably want to test that. Let's go ahead and just do a test here. If array y is null, then I'll probably want to print something. So I'll do, in this case, I'll do a printf. Could not allocate row, whatever row I was on. And what row was I on? I was on row y. And then probably should do something here to clean up the memory I've already allocated. That's probably the best way to do it. In this case, it's a demo program, so it's going to return back the operating system. Yeah, I really should do something to clean up the memory that I've done. Oops, I forgot that. So, all right. So now that I've done that, let's go ahead and store data in each of my cells. So now that I've done the allocation for each row, let's go ahead and store data in each cell, and that's going to be in each x y coordinate, or really it's going to be each y and x coordinate. So let's go ahead and do a loop here for y equals 0, and y being less than the number of rows, y equals I plus 1, plus 1. And then inside that, I want to have another for loop for x equals 0, x being less than the number of columns, then x gets incremented by time. And then I want to store in there a number. So let's go ahead and store into array. Now, normally I would just do a single, that's how we reference a single element of an array, but this is a two-dimensional array. And so inside y and then x, at that two-dimensional location, I'm going to store a number. And I want to do it this way. I want to actually show kind of the x and y coordinate that we're at. I could do a simple y times 10 plus x, right? That's a simple way to do it, and that way on row 0, the 0th row, it would be 0. But for the let's say the third position in on that row, this would be a 3. Unfortunately, that's a little simple to see because for the 0th row, it's going to be a little weird. So let's go ahead and add 100 to that. And that way, it's going to be guaranteed to have the Y position and the X position just with a 1 in front of it. So that way, it's just a way to kind of see what we've done. This will make sense when I run the program as a demo. And let's go ahead and print the value of the array. And so we'll just do a printf. I could do another loop to run through it. I could do one loop to store it, and I do another loop to print it. But we've already stored it, so let's go ahead and just immediately reference it. And then we'll say at yx. Let's actually put in the values here for y, and the value for x. Oops. Is now the value at yx. There's our new line. So I want to put in yx, and then the value at yx is array yx. And that should print out the y and x coordinates, and then the value at y and x. And that should be my loop. And when I'm done, well, normally I would just return 0, but remember, we need to free up the memory that we've done, so free the memory. Before, we just did a single loop to free up our, or we did a free of whatever our array was, right? Remember we did that before. But this is a two-dimensional array, so actually we need to free up in kind of the reverse order that we used it. So we're going to go ahead and for y equals 0, y is less than rows, y equals I plus 1. And then what am I doing here? I'm going to free that element, or that entry in the array list, array y. And then when I'm done doing that, I'll just go ahead and free the array itself. Now I'm done. So before I compile this, let's just make sure we know what we're doing here. So we've got a two-dimensional array called array. We've got one variable that's going to store the number of rows that are in it, and another variable that's going to store the number of columns on each row. And then I got two variables here that'll just store y and x. We're going to use looping. So here we're going to reserve memory for the list, the first list, because a two-dimensional array is a list of lists. It's an array of other arrays. So what this is doing here is doing the first array, sort of the parent array. And so we're doing malloc of the number of rows. And we're testing if that succeeded, and if it didn't succeed, it'll just print out a message and exit. If it did work, then we're going to loop through each row, and we're going to allocate memory on each row. And then if it didn't, for some reason, allocate, we'll just print out a message. Hopefully we won't see that. And then now that we've allocated memory for each row, now I have memory for the entire list of lists. And now I can allocate through each row and then each column, and then I can store a number in there that should be unique for every one that we're looking at. And then I'm going to print out what that value is, and then we're going to go ahead and free everything. I'm going to free all the rows. It's going to free the array itself, and then it's going to exit back to the operating system. So go ahead and save that. And I16 GCC, we're going to turn on all warnings to make sure we didn't make any errors. And then we're going to save this as 2D array .exe, compile 2darray.c. Make sure I didn't make any errors. Somewhere in there I made an error. What did I do wrong? The incompatible type, and that is oh, oops. Go ahead and so what did I do wrong? I actually was trying to store. I think I said this wrong earlier. I was trying to do int star. Really, it's two-dimensional array. So I'm trying to preserve a list of lists, right? That's what I'm doing here. So instead of int star, it's int star star. Go ahead and save and quit. Go ahead and recompile that. This one should give me no errors. And now let's run 2D array. There we go. This is a sample of how to do a two-dimensional array. So you can see that for every y and x, it's stored a specific value that we can kind of see in here. So at 0, 0, it's 100. At 0, 1, or y of 0 and x of 1, it's going to be 0, 1, 1, 0, 1. And so on down to the end where it's at y of 2 and x of 2 is 122, and y of 2 and x of 3, which is the furthest you can go in the array because there's 3 rows and 4 columns, 0, 1, and 2 for the rows, 0, 1, 2, and 3 for the columns, is going to be 123. And that's how you do two-dimensional arrays. Two-dimensional arrays are really just lists of lists. And I showed you in the other video how to do single-dimensional arrays as either using malloc or just defining it when you compile the program. But that's how you do a two-dimensional array in C. So before I stop, I just want to thank everyone on Patreon who supported me. Some of you have supported me at a higher level, and I wanted to thank you here. And I thank everybody who supports me on Patreon. You really do help make this channel happen. But what do you think about this video? If there are other videos you'd like me to cover, let me know in the comments below. This video itself is from the C programming series. Visit our website at freedos.org. Join us on Facebook, follow us on Twitter, and consider supporting me on Patreon. Thank you.